Hey, hello. You're stuck in traffic with Wolf Gore, like a couple-minute riff on IT and IT security. You know, when it comes to any of our systems, we always want to do features, we want to do performance, we want to do security, we want to do all these things. And of course, it's always a balancing act. You can't do everything. You can't meet all requirements. We don't have unlimited resources. But very oftentimes, that very real fact is used as a stopping point to do other things. So someone might say, hey, I don't want to do security X because it would impact our performance. And sometimes that's accurate, and it always bears looking into, but other times it's not so accurate. Other times it's more of a concern born out of a misunderstanding of the technology, or perhaps born out of a misunderstanding of how the system is architected, or could be architected to not have any performance issues. So for example, let's take databases. When we started denormalizing databases, we heard the exact same things. We don't want to have a denormalized database because there'd be performance issues. The joins are expensive. Putting the searches together would be expensive. Creating views and query sets would be expensive, right? And yet when we did denormalize, and you had, the user table, and you had the address table, and you had payment table, and you had health information table, all these sort of tables, and you join them and do searches and everything. It made maintaining the structure much easier, and it also meant that a whole slew of other things downstream got simplified. But the performance issues we were all very scared about and concerned about, and everyone was pushing back on in the early days, never really materialized. And the reason for that was we designed our databases correctly, we designed our applications correctly, and we took advantage of this new structure to push the system forward. So now when we say, well, we don't want to encrypt our databases because it will have a performance hit. I remember those early data warehousing days, and I'm like, yeah, would it really? Have we really looked at it? Now, to be clear, encryption is a million different things. So if you're talking about encrypting databases, you may be talking about TLS to log in or send the packets back and forth to the middle tier. We may be talking about disk encryption because you have some ridiculous requirement that says you got to do disk encryption on the database server. See yesterday's video on how to do that. We may be talking about column level encryption, right? This particular column needs to be encrypted so no one can read it when up. And column level encryption is in fact pretty heavy. Disk encryption tends to be pretty heavy. We may also be talking about format preserving encryption, which of the ones I just talked about, excluding SSL. So of column encryption and disk encryption is probably the lightest being format preserving, because then what you have is you still have your address table and it still looks like an address table, right? It's just jumbled up. It looks like a word, but it's not a word, right? It's format preserving encryption. You may still have a social security number that is a social security number. It's just not your social security number. And these format preserving encryption algorithms too have gotten pretty advanced. So it can preserve the last four, right? Which is usually what you do for authentication. Please tell me your last four digits of your social security number. And encrypt, mask the other ones. So it still looks like a social security number, it's just not your social security number. Same thing with credit card numbers. Still looks like a credit card number, it's just not your credit card number. The last four match, so you can do some validation. It's just not a valid encrypt or number. So format preserving encryption for names, for addresses, for health information, for payment information, social security number, all that sort of stuff is interesting and is ideal, because on a database layer you're not decrypting and encrypting. Ideally it's the exact same database structure you have, doing the exact same joins and everything we've done for years without incurring a payment or a performance penalty. Performance penalty of course comes in encrypting and decrypting. We know this. The performance penalty of encryption is usually overhead and time to decrypt and encrypt. So what do? Let's suppose you move that to where the user is expecting to be a delay. And let's suppose you do some clever things like do the encryption on the application layer. Let's suppose instead of decrypting all your columns to search for a social security number, for example, let's suppose you encrypt the search request and search on that. Now the lookup is doing encrypted data across an encrypted data column. So your data tier is still the same, your application tiers is still the same. The delay is only 1 hit, not a million hits if you got 10 million rows you're searching. And that 1 hit delay is within the application when the person clicks search, which people are already expecting a little bit of expecting when they act in the app. So by doing things like that, taking advantage of when people are expecting encryption, expecting time delays, taking advantage of architectural choices such as encrypting the search results rather than decrypting all the search items, you can run at or near normal performance using FPE. Kind of interesting. All it takes is some good designs and a lot of luck. And it should be easy, because everything's easy. All right, maybe harder than I'm making it sound. But anyways, thanks for joining this video. I'll talk to you later.